Hello everyone. Today I'm going to give a presentation on how you can create a live boot Linux from scratch. So the agenda is I'm going to go over a few assumptions. I'm going to explain the process of what you need to do in order to get your LFS machine into a bootable USB. And then I'm going to go through some of the make scripts I've made to automate this process. So the assumptions are that you've already gone through the process of building an LFS and that you've done this in a virtual machine, specifically a QEMU virtual machine. I don't know how to, I don't use VirtualBox very often, so I'm not sure how to do it with that. However, doing an LFS, although it's time consuming, it's actually incredibly easy to do. But if that's a little bit daunting for you, there is a project up on GitHub called PhysixProject. I've never used it myself, but it looks pretty interesting. A method of automating Linux from scratch. The automated Linux from scratch project is more about testing that the instructions in the LFS manual work properly. And I'm not sure if it's a really good way to automate Linux from scratch itself. You might want to use a different method of doing automated Linux from scratch. However, I highly recommend that you do a manual Linux from scratch at least once, probably twice is best. So hopefully you've still got your build machine, your host, kicking around, the machine that you use to build your Linux from scratch virtual machine. Now you should be able to do all of the instructions I have here on a brand new virtual machine, such as CentOS or Ubuntu or something like that. But I think you need to ensure that the host tools, and Linux from scratch gives a page where they tell you how to make sure that your host tools are all set up. And you need to ensure that those host tools are still present. So if you're interested, I can make a video about how to do a Linux from scratch under QEMU. Like I said, it's incredibly easy, but it's very time consuming. It took me about 4.5 hours to get my Linux from scratch up. So yeah, the process. And this is the setup part of the process. So you need to start your host machine with your LFS drive available to be mounted. And in my run scripts, it's simple -A, and you give the image that the LFS would run on. The next thing you do is that you mount your LFS partitions to a directory. You grab BusyBox, and you can either grab BusyBox in source format or just grab BusyBox as a pre-built binary. You need to make an init script for BusyBox, but we'll get into that later. And you also need to grab syslinux. So what you do to make your live CD is that you take your LFS root partition, which is mounted into a directory on your host machine, and you use make squash fs to squash it down into a single file. You then create a basic directory structure for an init ramfs, and you copy into that structure BusyBox and your init script. You then use CPIO to create the init ramfs as a single file. You then create a directory that holds the files from isolinux, which you got from syslinux, and then you populate that directory with the required files, and those are isolinux.cfg, which is, well, I'll get more into that in the next slide, all the kernels that you want to boot, the file called isolinux.bin, the file called ldlinux.c32, and your squashed LFS root partition that you made at the beginning of the slide. So the real magic is in the init file and the isolinux.cfg. Those two files are files that you are editing. And so what the init does is it is part of the init ramfs. It is a bash script which is run through busybox bash. And it is the first user space application run by the kernel. And it does magic stuff to set up the system for the real Linux from scratch that you will change into after you've finished the init ramfs. The isolinux.cfg is like grub CFG. It's very similar to grub CFG, but it's how you give a configuration for the booting of a CD-ROM or a USB. So what isolinux does is it says, here's my kernel, here's my init ramfs, make it go please, for bootloading. So here's kind of a flowchart of the process of booting up into your Linux from scratch from a USB stick. So the first thing that happens when you power on the machine or you power up QEMU is that the system boots and it finds the ISO bin and the ISO CFG on your USB stick or your CD-ROM. So it goes from the system boot into the ISO Linux bootloader. The bootloader says, here's the kernel and here's the init ramfs. So we move into the kernel. The kernel then loads the init ramfs and it runs that busybox init script. That busybox init script does a mounting of the squashfs file system from your LFS root. It mounts an overlay FS so that you can make changes, not permanent changes, but it makes it so that your LFS isn't read only. I'll get more into that as I show you the init script that I have. And then what the init script does is it does a switch root command to the systemd, and then systemd sbin init takes over, and you're into your login prompt. So let's take a look at some of the scripts I have to automate this process, and I also want to show you my init for the init ramfs and my isolinux.cfg. And all of this code can be found up on my GitHub page at masmullen2000 LiveScratch. So let's go into GitHub and go into the LiveScratch area. And I am going to zoom this in so that it's easier for you to read. So let's take a look at the isolinux.cfg first of all. So isolinux.cfg is a pretty simple bootloader configuration file. And all it says is that I want to display a file called boot.txt. And let me quickly show you that. So it's just a fun little ASCII art saying welcome to LiveScratch, and then it gives options about what you want to boot. Then it gives you 10 seconds. So that 100 is actually divided by 10, meaning it's 10 seconds to either go into label 1, which is a pre-configured kernel that I haven't built with Linux from scratch, or the kernel that I built from Linux from scratch. So I actually made a few changes here that I seem to have forgotten to push up and are now lost to time, but this will get us through what we need to do. So when your machine boots up, you will be presented with that welcome to LiveScratch ASCII art, and then you'll be able to press either 1 or 2 to start booting up your your kernel and your initramfs. Now, the second thing that we want to look at is the init file. So this is where the real magic happens. And the important things here are that what we're doing is that we're giving us a few seconds for the CD-ROM to be CD-ROM or USB stick to be recognized by the kernel. Then we make sure that dev is populated, /dev is populated with all the information that the kernel has found out about the machine, including where the drive of the USB stick is. Then we grab the location of the USB stick via a block ID call. We look for the volume, and then we get that into a variable called drv. We mount that drive, which will sometimes be /drv/sr0 if you're mounting as a CD-ROM, or it might be /dev/sda1 /sda if you're mounting it as a USB stick, or it could be SDA2 or back up. It's going to be /dev/sda, or it could be dev /sdb or SDC, SDD, so on and so forth. What we're going to do is that on the CD-ROM there, we have our squashed file system, which we mount into a directory called RO, and that's because the squashed file system is read-only. So we want to be able to read and write to our root partition when we're finally into Linux from scratch. So we mount a tempfs onto mntrw, and then what we do is we do an overlay file system, mounting that the squash fs onto various directories that we've given inside of this tempfs area. And we mount that finally to a directory called mnt-rootfs. So in the end, after all this process, at the end of this call, if everything goes well, we will have our a copy of our LFS root file system inside of mnt-rootfs. What we then do is we exec to switch root onto that rootfs area, and we ensure that sbin init is called. The reason why we're using exec here is because everything in this file right now is running as PID1, and sbin init from systemd also needs to be PID1 to run properly. So let's give it a run here, and then I'll go through the makefile. So what I've got is I have a CentOS virtual machine that I use to make my Linux from scratch, and it will do to make the live CD for this Linux from scratch. So the things that I need to do is I'm going to run it as a daemon, so it's detached. I'm going to run it headless. I'm going to give it an SSH port at 1234, and I'm going to give it the location of my Linux from scratch my Linux from scratch hard drive. So, and then I'm going to give it a few seconds to boot up. And I'm going to SSH into the CentOS machine. And I'll go into this code area, and I will grab the LiveScratch code I have. So I don't want to add a file. I want to clone this. Right. I will then go into the LiveScratch directory, and then I will do a make. First, we should do an lsblk to see where our Linux from Scratch drive is. And here's our Linux from Scratch. So I'm going to issue a make mount drv equals dev sdb. Not sdb1, not sdb2, just sdb, because it will mount both my, this is my root partition, and this is my boot partition. So go ahead and do that. And now inside of LFS root, I have my Linux from Scratch root file system. And if I make changes in here, it will be reflected when I boot up my LFS. And in boot, I have my boot partition. So I am going to get a bug here because I have two VM Linuxes, and I previously made some changes to deal with multiple VM Linuxes, but right now I am going to do a change to my LFS boot, and I'm going to change that VM Linux 5.8 to LFS boot old VM Linux. I need to do that as sudo. All right, so the next thing I'm going to do is I'm going to issue a make USB. So this should do everything that we want it to do to give us an ISO file that is bootable, from USB stick. So hopefully this goes well. And we're grabbing BusyBox. We're building our SquashFS file system. And then we're grabbing syslinux. We're populating our syslinux area, and then we're building an ISO out of all the kind of compiled up components. And then we're issuing an ISO hybrid on the ISO file. And this ISO hybrid command makes the ISO bootable from USB. So we've got an LFS ISO that should be bootable from USB drive. So let's test it out inside of a QEMU image first. So I'm going to switch to my virtual machine area, and I am going to grab that file, that LFS ISO, and I'm going to move it to my real host machine. And then I'm going to give it a run, saying that it's going to be run as a CD-ROM. And I'm going to turn off my tiling so it doesn't cause some weird pop-up stuff. All right. And here we are. Zoom that in. And we're running LFS from an ISO image. So this doesn't necessarily prove that it's bootable from a USB stick. But luckily, I have a USB stick and another machine here just waiting to go. So I'm going to shut down this QEMU image. And what I'm going to do is insert a USB stick into my computer here. And I'm going to find out where that USB stick is, and it is SDG. And I am going to copy it onto my USB stick. All right, let's make sure that it's fully synced. Yep. Remove it from my computer here and insert it into my Lenovo X1 Carbon. And this is a Lenovo X1 Carbon Broadwell, I think. It's the first 14 nanometer Intel chip that they made. So it's, I think, 5 years old. I'm not quite sure, but it's an older Intel machine, and everything that I've done here I've made on an AMD Ryzen 2 machine. So I've inserted it into my Lenovo X1 Carbon. Let's switch to seeing the X1 screen, and I will boot up. Ask it to boot from CD-ROM, and I realize that you can't see any of this because the screen is only mirrored kind of halfway through boot up, but I'm going to choose that kernel, and you should start seeing things right about now. There we go. So I am on the X1 Carbon, and I am in my Linux from scratch. I have a network on it. Now I haven't figured out how to get wireless networking working on it yet, but we're able to like get wget http :/google.com. So we've got a little Linux from scratch here ready to go. So there's a few other fun things that we can do. I'm going to shut off the Lenovo. And move back to the main window here. So that will give us a machine to a stick to just insert into hopefully any machine. The only machine I've tested this on is my X1 Carbon here, but I'm hoping that it works on other machines. I don't know. But yeah, we've got a USB stick that we can stick into a machine and get a little Linux from scratch running on it. But there is more that we want to do here. What we want to do is be able to install a Linux from scratch onto a machine from this USB stick. So I've also done some work to get that done as well inside of these scripts. So I'm going to do a make DC, which means deep clean, and it means I'm getting rid of my syslinux and my busybox here. I'll re-download them. And I'm going to make the USB stick again, but this time I want to say tar equals yes. And the reason why I'm doing that is because I am tarring up my root partitions, putting them into the CD-ROM image or the USB stick image, in the hopes that when I boot this up on another machine, I can untar them onto that machine. And I'll give you, it's easier to do rather than to describe. But yeah, because I'm doing a tar of that entire file system, it's going to be a bit slow because I'm doing maximum compression through XZ. So I'm going to pause the video here and we'll wait till this gets done and then I'll show you how to install Linux from scratch from a Linux from scratch live USB stick. All right, we're just about finished making that lfs.iso. And this is a good time for me to open up the makefile and tell you what's going on here. Let me open up for raw and zoom in maybe a little bit. So the main target that I'm doing is USB. What it's doing is it depends on lfs.iso existing. So I'm going a little bit backwards. I need to start from the start. So the start is we grab syslinux and we grab busybox. So we grab those and we put those into a resource area over here in resources. So if we take a look inside of resources, we now see that it's got busybox and it's got the needed things. So it's got this LD Linux and isolinux.bin. So those are the two files I'm getting from syslinux, and I made this isolinux myself. So it's copying those into the resource area. What it's then doing is it's going to go about making the init ramfs system. So it's creating a basic directory structure consisting of bin, sbin, etc, proc, user, user bin, user sbin, dev, sys, mount, and mount/rootfs. It's then copying busybox and the init script into that directory structure and using CPIO to create the init ramfs to create a file called init.gz, which is my fully completed init ramfs. So the only thing in there, let me give a make ramfs here. So the only real file in here, the only two files in here are busybox and init. Those are the only real two files in here. Busybox populates everything in bin with soft links to itself. So that's the way that busybox works. Busybox is a single binary that knows how to do a whole bunch of stuff, including run bash, run mount, a whole bunch of different utilities. So we copy those, we make the ramfs file system. We're then going to make a squashfs file system. So what we're going to do is, in the normal scenario, we're going to ensure that we don't have an fs tab, because the fs tab that I have for running for my normal LFS running is not compatible with a live CD. An empty FS tab is just fine for live CD though. So I make sure that I've got an empty FS tab. I then make a squashfs file system, and I exclude the sources and the tools directory because that's just a lot of data that I don't need to grab. I put my FS tab back, and if a directory called image exists, I then delete it. So in the case that we're doing the tar command, I am tarring up the root. I'm tarring up the root file system from my LFS file system. I'm tarring up the boot partition from my LFS file system, and I'm copying those into my root file system as those tarballs. So essentially, when squashfs runs, it will have two tar xz files containing the file system and the boot partition. So yeah, if you, and the reason why I'm doing that is because you can then boot up the ISO and untar those onto a hard drive, and LFS is made in such a way that it will boot up from there. Now, I will prove that to you in a few minutes. So we've got the SquashFS file system, we've got the RamFS file system, and the last thing that we do is that we're going to make the ISO. So we make this ISO Linux directory, and we populate it with a bunch of resources. Those resources are the boot containing the ASCII art saying welcome to LiveScratch, the ISO Linux bin file that we got from SysLinux, the LDL Linux file that we got from SysLinux, a kernel that I've pre-compiled and that I know works. What I mean by I know it works is that it's been configured to have SquashFS and OverlayFS inside of it so that it will be able to do the things that init wants to do. So just to remind you, vim resources init, it will know how to do these commands. Because not every kernel knows how to do those commands, and those commands aren't necessarily in the def config. If you just run a make def config, you will not be able to populate those. And in fact, I'll keep going. So, and then it populates also with the bootloader configuration file. Once those are all in this ISO directory, it's going to use make ISOFS to package that all up into an ISO file, and then it will run the ISO hybrid to make sure that it's bootable as a USB, not just as a CD-ROM. So take a look at this makefile for yourself. Hopefully, if you don't use it, it at least gives you ideas on how you can do this for yourself. So I'm going to get out of here. And I've got the ISO already made. Yeah, there's nothing to be done for it. So I am going to copy it onto my Fedora machine, and this is the hardware machine. This is the real machine that I'm running. So I'm going to copy that on over. And I'm going to make a QEMU hard drive so that we can install LFS onto a hard drive-like concept. So QEMU image create -fqcow2, and I'll call the image name testlfs.image, and we'll give it 10 gigabytes of size. I'm fairly sure that we only need 2 gigabytes, but I'm just being generous here. And then I am going to run this with my testlfs image and the CD-ROM as my lfs.iso that I just copied over. So welcome to LiveScratch, and we're going to boot into the pre-made kernel that I know works. And we're going to log in and issue an LSBLK. And we see that we've got this, I can't use my pointer here. We've got this SDA hard drive, this SDA disk here. So what I'm going to do is I'm going to go into the mount directory. I'm going to make dir a root fs, and I'm going to mount that. No, I'm going to cfdisk dev SDA. And we're just going to make it a normal MBR drive. We will first make a 256 meg boot partition. We'll then make a No, let's make the swap partition first. So a new 2 GB swap partition, and then a 256 meg boot partition, and the rest of the space will be used for our root file system. And we're going to change this type to swap, and the other two are Linux, so we will write this out. Yes, for sure, and quit. So now inside of dev, we should see that we've got SDAs. We've got SDA 1, 2, and 3. So we're going to make swap on dev SDA 1. We're going to make fs.ext4 on dev SDA 2 and 3. No, I've already did it. All right, so now we will mount our dev SDA 3 to mnt rootfs, and then we will mount dev SDA 2 onto mount rootfs boot. Oh, right, because we haven't populated it yet. Okay, so before we mount our boot partition, we want to untar. So where are we right now? pwd, let's go into rootfs, and we want to tar xvf on images.root, and we're going to put that to mnt rootfs, and I hope this does the directory structure properly. All right, now we're going to mount that boot partition. All right, and we will then tar xvf the images.boot into mount rootfs boot. All right, let's go into rootfs and check out that we've got the things that we think we have, and we do. Okay, so we've got ourselves the drive is populated with the things that it needs, but now we need to configure up grub. So we're going to go into mount rootfs boot grub, and we will edit our grub.conf here. So I think this might be wrong. We shall see, but this needs to change to a 3, and this needs to change to a 3 as well. Now, we need to issue a grub install, and I forget all of the commands. So let me just run on over to the Arch Wiki and look for the installation. No, we want to look for grub. And this is part of the command that we want to do. Grub install target equals i386-pc, and we're going to do it onto dev SDA, And there's also something that we need to do. It's root. Let's take a look at the man page. Oh, nothing there. All right, we're going to go to here, man grub. Man, I don't have man pages for grub anywhere. I need to specify that my root is not / it's mnt rootfs. So we're looking for root. Root directory. Okay. So grub install -- target equals i386 PC to dev SDA, and then we give it this root directory equals mnt rootfs. All right, let's hope this works. Target equals. Okay, let's shut this down and give that machine a boot up. Let's see if it worked. Okay. So now we're just going to run test LFS image without the CD-ROM. So cross your fingers, everyone. Here we go. Nope, I have made a mistake somewhere. Wonder what I have done. Ah, yes, okay. So we're going to quit this. Back into the CD-ROM. And go into mount again. We have to, nothing is permanent on the live CD, so we have to make the directories again, but we don't have to format or anything. We can just make the dir and mount it up. Dev SDA 3, was it 3? Yeah. T rootfs. Mount dev SDA 2 as mount root fs boot. So I believe that rootfs boot grub.conf. I believe we have to change this. And I'm not sure if we... So what is it on my normal machine? My normal LFS has... What is my normal LFS? I think the first one is my boot partition. The next one is swap. No, the second one is my root partition. The first one is... let's just give it a shot here and just change it to 2, see what happens. And that grub install target equals i386 PC dev SDA root directory equals mnt rootfs. And I actually didn't need to do that, but I just needed to change the grub.conf. Okay, So shut down now. There we go. Oops. So there's still something wrong here. What went wrong? System control unit, list unit. Wonder what failed here. Well, I've got a little bit more work to do. Oh, you know what? I bet it's my FS tab isn't correct. So let's go into Etsy. Right, okay, so let's change up this FS tab. So my root partition is number 3. My boot partition is 2, right? My swap is 1. So yeah, swap is 1, boot is 2, SDA is 3. Okay, so let's reboot this and see what happens. There we go. So now we're up and running. We've got we have installed a Linux from scratch from a Linux from scratch live CD that we created from a Linux from scratch. So now we have 3 Linux from scratches where we once had 1. Thanks for hanging around while I did a bit of debugging here, getting my FS tabs correctly and everything like that. And I hope you've learned something about Linux. And thank you very much and happy hacking.